Hi, in this lesson we're going to take a look at additional loop examples for ArrayList. In previous lessons, we have seen how you can traverse an ArrayList using a for loop. Using a loop index variable I, we can systematically traverse through an entire ArrayList. As with other for and while loops, we can see that they're interchangeable and we can traverse with either a for or a while loop. Both loops initialize a value, check against a Boolean expression, and increment a loop variable. The code is nearly identical, just placed in different places within your program.
Because ArrayLists can change size, we have to be careful when traversing them, as the changing size can affect which elements are being accessed. Let's say we wanted to create a method that removed any item from an ArrayList that started with the capital letter A. We might start by writing the method declaration. Here's what the full method might look like. We loop through the list from index 0 to index list.size -1 and remove any item that starts with the capital A. When we run this, however, we run into a slight problem. Let's take a look at this in action with the above ArrayList list. The for loop initializes the variable I to the value 0. Because I is less than list.size, the for loop will run. Since the index does not contain a value that starts with a capital A, the if statement is not executed, and the for loop begins again. The increment increases the value of I by 1, and the for loop initiates again. The second index value also fails the if statement because it is looking for an uppercase A, not lowercase, and the program continues to the next line of code. The increment raises the value of I to 2, and the for loop is initiated again. This time, the value of index 2 does start with the value capital A, so the if statement will execute. The value Andrew is removed at the index 2, and the values greater than index 2 shift downward to take the place of the removed index. The increment then increases the value of I, and the for loop runs again. This time, the value of index 3 returns false, and the for loop concludes its iteration. As we can see, there's a bug in our program. The program never actually accessed the value aardvark because when the value Andrew was removed, the value aardvark was shifted to index 2. Because the for loop increases the index to 3 after the end of the loop, this value never gets evaluated and ruins the successfulness of this program. Can you think of a way to fix this? We can avoid these kinds of issues by adding an I ---- after the remove method in the if statement. Let's see how this prevents this issue from occurring. Let's return to where we removed the initial value Andrew. When we remove Andrew, all the values greater shift down in the ArrayList. When we add the I ---- command to the program, the value of I decreases from 2 down to 1. Now when the for loop is initiated again, the same index, 2, will be accessed when testing the index values. When we run through the loop again, the value in index 2, aardvark, is tested against the if statement, and is then removed from the list. When creating while loop traversals, we also need to consider the same issue. In this case, we only increase the value of index when the index isn't removed. If the value is removed, then the index doesn't increase, and the program will check the same index the next time around. Unfortunately, trying to use remove when using an enhanced for loop will often result in a concurrent modification exception. This error occurs when objects are being modified while they are being iterated on, which is what happens when we use enhanced for loops on ArrayLists. Generally speaking, we should not use enhanced for loops if we are adding or removing items from ArrayLists. Some standard algorithms also require arrays and ArrayLists to be traversed simultaneously. For example, if we wanted to sum the indices of 2 ArrayLists, we could do so by traversing both of the ArrayLists at the same time. Let's take a look at how we could do that. First, let's start by creating a SumArrays method declaration that takes the inputs list1 and list2, which represent 2 ArrayLists of integers. Before moving on, can you figure out what steps we would need to take in order to implement this method? Here are all the steps that it would take to implement this SumArrays method. First, we would need to initialize a new array list. This is the list that will be returned from SumArrays with all of the updated values based on the sum. Next, we need to create a traversal that will allow us to go through the values in the array lists. Since the two array lists are the same size, we can just choose one of their sizes and set the traversal to end at the last index of that list. Next, we can add the two values at the same index from both array lists together into a summed value. Even though we've created one traversal, we are traversing through two array lists at the same time, grabbing the index in the same location and assigning it to the value sum. Next, we can add the sum value to the summed list, which will put the sum of both array lists in the same index location in the summed list. Lastly, we can return the summed list, which will have the summed value of list 1 and list 2 at each index. It's important to note that this will only work correctly if the array lists are the same length. When traversing array lists, you must pay attention to the size of the array lists to make sure that traversing won't lead to errors.
One last thing to note. We are actually able to write array lists without specifying the type that will be included in the array list, but specifying the type is highly recommended because it allows the compiler to find errors before runtime. This makes it easier to find errors and program more efficiently, as the program will indicate there is an issue before the code is run.
Now that you've learned more about developing algorithms using array lists, let's get some practice using them in the editor.